Nobody go and ask your tuition teacher, meh? Don't know how to do? Or ask your parents, ask your siblings, your eldest sister, brother, your auntie, uncle. Okay, look at this. So far, only I think Emmeline Tan tried, then she say cannot do. Okay, and then Yenny tried, then this is what she gave me. You all can see at the side here. Actually, it's good enough, but I comment on hers. This one we normally don't do in this way. This part we don't write it out as a all this number. Although she put this in ratio lah, but normally we don't do it this way. So how to write it out properly? Okay, so you can see this one. Okay, this one she used a similar triangle. Okay, to get the ratio. Okay, so CM, CA. Okay, CM here. Okay, CA the whole thing means the small triangle and the big triangle. There I got mentioned, right? I think so. Okay, you have to use a similar triangle. Okay, so this is a small triangle and this is a big triangle that are similar to each other. So small triangle, this side is CM, so over CA. Okay, it will be equal to a CN and then CB. CN over CB. And also this one, MN over AB. Okay, because MN over AB, this is a 1 over 2. Okay, from the midpoint theorem, we know that the MM over AB is 1 to 2. Okay, and then there is one more ratio that we can get from the similar triangle that we need to use to find the area of a triangle. You all can hear me, or you all can see what I'm sharing now. Yes, sir. Can. Now I'm talking to myself only other. Okay, one more thing that you need for find the area of triangle will be the height. Okay, because after we're going to use the MN as a base, so the height will be here. Okay, so I draw dotted line, dotted line. Okay, this height must make 90 degree with the base, make 90 degree with the base. Okay, so if okay, I label this one as P. I mean this point, and then this point as a Q. Okay, therefore another from the similar triangle, okay, the ratio also is 1 over 2 will be CP. CP over CQ. Okay, then all this, the ratio is 1 over 2. Okay, now, okay, we want to find first area of a triangle CMN. Okay, so area triangle CMN. Okay, we write out the formula half times the base, okay, which is the MN, okay, times the height, which is the CP. Okay, then area of a quadrilateral ABMM. ABMM. This one I'm going to use a big triangle minus a small triangle to get, okay, the balance will be the area of a quadrilateral. Okay, so you see, Yenny also do the same thing. She get the big triangle minus the small triangle. Okay, so area of a quadrilateral ABMM is, okay, big triangle is half, the base is AB, and then the height is CQ. Okay, minus this one, no? Okay, half MN and then CP. Okay, now how to relate them? Okay, I try to change, since this is MN and CP, I try to change the AB and CQ in terms of MN and CP using this relation. Okay, so first of all, I extract out mn AB is 1 over 2. Okay, I only take this and this. Okay, so cross. Okay, so AB is equal to 2 mn. Okay, next, how about CQ and CP? Okay, so I'm going to take this and this. Same thing. CQ is 1 over 2 cross. Therefore, CQ is 2CP. Okay, so here I continue. AB with the 2 mn. CQ as the 2CP. mn CP. Okay, so this one is simplified a bit. So this one you have a 2 mn and CP and half mn and CP. Okay, then you have a MNCP. Okay, so this is like a like term already, so you can combine it. Okay, so 2 minus half, so it's 3 over 2 mn and then CP. Okay, now you can write out the ratio. Okay, so I write out CMN. This is area is to AB and N area. Okay, so CP is 2 and N CP. Okay, now here, this one you can cut. Okay, so your answer will be, okay, times 2. Okay, so you have 1:3. Okay, this is how you prove. This is 1:3. Same answer like in your book. Okay, if you feel confusing with this MN, CP, all this, you can just write alphabet represent it, maybe H for the height, H1, H2, or small h, capital H, up to you. Okay, this part okay, you know why it can cut in this way, because is 2, the meaning is same as a divide. Okay, so you can imagine this is over this. That's why denominator and numerator you can cut. Okay, so this is how you get the answer. So this one you copy down in your book. Okay, so far nobody WhatsApp me any questions from your textbook exercise. So we continue equation of Loci. This one you have learned during your Form 3. Okay, so I have asked you to do the revision. So I hope you have gone through your revisions. Okay, we come back to the textbook. Okay, so this one will be the today index. Today is 15.
Should use what book? Must use what book?
Still the same book. Okay, until we change to different chapters, then we use another books. Okay, this one still in the same chapters, chapter 7. Okay, we go to this. Okay, what's the meaning of locus? Okay, this one actually you learned before. Okay, locus is a moving point. Okay, is the path taken by the point subject to a certain conditions. Okay, so locus usually you have a condition given, so you only can form a locus. Okay, so during Form 3, you are learning maybe draw the locus. Okay, and also you learn they give you the condition, you have to know what type of locus is that, but you didn't learn what is the equations of the locus. Okay, so for Form 4 and Maths, you're going to learn what is the equations, okay, of the locus. Okay. So we continue. Okay, so how we get the equation of the locus? Okay, usually, okay, we are using this. Okay, the example, the formula of a distance between 2 points. Okay, and then also some other formulas. Okay, this one where we will study case by case. Okay, depend on the given conditions. Okay, but this is very popular. Okay, using the formula of a distance between 2 points. Okay, then to get the equations. Okay, this is when we set the moving point, okay, as a x and y. Then you use a formula of a distance between 2 points, then you will involve the x and y. Therefore, you at the end, you will form an equation in x and y. Okay. Okay, now we look at part A. Okay, this is the first type of locus we're going to learn. Okay, this is the first part. Okay, so this one you can copy. Okay, so this is the first one we're going to learn. Locus of a moving point form a fixed point is constant. Okay, the distance from a fixed point is a constant. Okay, this one actually you know already. If you do revisions, okay, you are going to get a circle. Okay, but if you know this is a circle is not good enough for MS Form 4, you need to write the equation out. Okay, we go to this. Okay, now you see. Okay, you see the moving point is the P. Okay, usually the moving point you label it as a XY. Okay, so that you will get the equations in XY. Okay, I go through the textbook. Okay, let's point P XY is a point of distance R from a fixed point. Okay, the fixed point is the A, okay, x1, y1, okay, where R is greater than 0 because distance usually is positive. Okay, move point P and observe, okay, move point P. Okay, so means, example, this distance is fixed. Okay, so now the P is moved in the way, always the same, keeping a same distance from the point A. Okay, I try and see, move. Okay, can see the red color dot actually is tracing, okay, and always is the same distance, keep a same distance, okay, from the point A. Okay, so at the end you are getting a circle. Okay, so now how we want to find the equations. Okay, I come back to the text. Okay, we are using this. We're using this, the formula for distance. Okay, so PA is the distance, okay, equals to R. The distance will be given, okay, this is R. So we just use this, okay. So this one you can copy, and then this one you copy. But this one no need to copy. You're not going to memorize it, okay? As long as you know the distance of 2 points of formula, then you do from that. You don't memorize this, okay? So we go to one example. Okay, find the equation of locus of moving point P so that its distance from the point A. Okay, point A here is the fixed point. Okay, is 6 unit. Okay, the distance is 6 unit. Okay, so we start with the PA equal to 6. Okay, we start with PA equal to 6. Remember, always the moving point, we got to set it as the XY. the coordinate. Okay, then by using these 2 points, okay, use the formula for the distance and then 2. Okay, so x minus x, so x minus 4 squared plus y minus y, so y minus -3, the whole thing squared. Okay, square root it. This is a formula for distance of 2 points. Okay, equals to 6. Okay, next, squaring both sides, so the square root disappear, the 6 become 36. Okay, because 6 squared is 36. Okay, after that, this one expand and this one expand. Okay, for the expansion for x minus 4, you are getting x squared 4 times 4, sorry, -4 times -4, positive 16. Then shortcut, -4 times x is -4x times 2, -8x. Okay, so this expansion, you are getting this one. Second expansion, y plus 3. Okay, do the same thing. Y squared, 3 times 3 is 9. 3 times y, 3y times 2, 6y. Okay, after that, group the whatever like term you have. But here, is only the number is like term. Okay, the rest are no. Okay, then after that, you got to rearrange in this way. X squared first, after that followed by y squared, after that followed by x, followed by y, and then only the number. Okay, remember this, move to this side. Okay, on the right is only 0. Okay, so this is how you get the equations of the locus of a circle. Okay, so this is first type of a locus. Okay, now we go to second type of the locus. Okay, ratio of a distance of a moving point from 2 fixed point is constant. Okay, you have a moving point. Just now is you have 1 fixed point. Now you're having 2 fixed point. Okay, the ratio from this moving point from the 2 fixed point is a constant. Okay, now we see what's the meaning. Okay, we look at this. Okay, here the 2 fixed point is the A and the B. Okay, so the P is the moving point. Okay, so you see, always a moving point, you put XY. Okay, so the fixed point here, they label for point A is x1, y1. For point B is x2, y2. Okay, R is 2. This is the ratio. Okay, the ratio of the P to A, okay, to P to B. Okay, PA over PB is 2. Okay, this is the meaning. Okay, let me see what I can show you. Okay, drag the point on the slider to the left and right so that the ratio changes and also the circle form. Okay, so this type of a question, you also will get a circle. Okay, if different ratio, what will happen? See, okay, now this is a 2.01. The ratio now is 2.01. Okay, I drag it to the right. So now the ratio become bigger and bigger. When the ratio become bigger, you will see that the circle becomes smaller actually, but it's still a circle. Okay, now I come back to 2. Okay, now the ratio become smaller and smaller, and you will see actually the circle become bigger circle. Okay, and then one more thing I want to show you is when I drag it become when the ratio become 1. Okay, what will happen? When the ratio become 1 means PA is equals to PB. exactly. PA is equal to PB. Okay, now 1.449. Okay, you see the circle still grow bigger and bigger. Okay, 1.23, 22, 14, very big already now the circle. Okay, 1.1. Okay, very big circle. Okay, when it's 1, you can't see anything because when the ratio is 1, this is no longer a circle. This is another type of shape you will see. And this one you have learned during your Form 3. Okay, imagine you have a 2 fixed point. Okay, and then you have a moving point that have equal distance. When the ratio is 1 means their distance are the same. Okay, equal distance from the 2 fixed point. Anyone want to try? What is the locus that you will get? Or what shape or whatever? You have learned during your Form 3. I repeat, the moving point have equal distance from 2 fixed points. Come on, you can type. You got device or not? Huh? At your lower form maths, you cannot say forgot already one. Your Form 5 will test back all your Form 1 until your Form 5 maths. You can say, I cannot remember. Give back to teacher already. Hey, hello, come on. Moving point. Equal distance from 2 fixed point. Yeah, perpendicular bisector. Ayo, Pechi, thank you very much. Okay, perpendicular bisector is the answer. Okay. Yeah. Okay, so for this part B, for this part B, okay, if the ratio is not 1, then you are getting a circle. If the ratio is 1, then you are getting a perpendicular bisector. Okay. Okay, so the answer is a circle. Okay, and then you can draw this diagram, and then this one is enough. Okay, this one no need. Okay, you copy this and you copy this. Okay, then you say this is a circle. Okay, this is actually B1. Okay, you can write a little bit. Okay, the ratio is not equal to 1. Okay. Then this is the second part under B. Okay, now this one is for the ratio is equal to 1. Okay, so that PA is equal to PB. Okay, same thing, this one no need to write, no need to copy. Okay, so you are getting perpendicular, okay, bisector, okay, of the line AB. Means if this is A, this is B. Okay, if you have a line joining up A and B, okay, the locus will be this. Sorry, this one I draw solid. Okay, so the locus I draw dotted. This is the locus that you're going to get. Okay, perpendicular means make 90 degrees with the line AB. Okay, bisector means it cut A, B into 2 equals parts. Okay, so this is the meaning of perpendicular bisector. Okay, so for the B, okay, remember there are two scenario. Okay, one ratio is not 1. Okay, the other one the ratio is 1. Okay. So now we look at the example. Okay, point P again. this is a moving point, so set this as xy. Okay, the distance from the point S and T is in the ratio 2, 1. Okay, so 2, 1, okay, PS over PT. Okay, PS over PT is 2 over 1. Okay, so we start from here. Okay, if difficult for you to write in this way, you can make the cross first. Okay, so PS is equal to 2 PT. Okay, so same thing, PS, P and S, okay, write using the formula of the distance in between 2 points. So x minus 1 squared plus y minus 2 squared, okay, equals to 2, okay, times, okay, now PT, so P and T, x minus 4 squared plus y minus negative 1, so plus 1 squared. Okay, after that, squaring both sides, okay, square both sides of the equations. Okay, so when you square both sides of the equations, okay, the square root here will disappear. Okay, remember the 2 you got to square also. Okay, the common mistake the student make is always forgot to square the number. Okay, they just take away the square root. Okay, so this one you get 4. Okay, and then this one after square it, the square root will disappear. So put bracket for it, x minus 4 squared plus y plus 1 squared. So after you expand this whole thing only times in the form. Okay, now after you expand this whole thing, then you only times in the 4. Okay, and then move everything to this left hand side. Okay, and then group the like terms, and then okay, you see check and see whether this is the simplest. Okay, if not, okay, see what is the common factor that everyone can divide to. Okay, so in this case, every of the terms can divide by 3. Okay, so you got to divide by 3. If you write this as a final answer, you cannot get the last mark. Okay, because always the final answer must be in the simplest form. Okay, so remember to rearrange. Okay, x squared first, y squared, x, the term in x, in y, and then number. Okay, and the right hand side equals 0. Okay, now we look at another example. This is the perpendicular bisector. Okay, find the equation of locus of a moving point Q such that its distance from point A and point B are same. Okay, so very simple, same thing. Moving point Q we set as xy. Okay, so QA is equal to QB. Okay, we start from here. Okay, then we repeat the same step. Okay, use a distance formula. Okay, and then square both sides. Okay, and then expand and then move everything to the left hand side. Okay, and then at the end, okay, you will see your equations actually is a linear equations. Okay, why is a linear equation? Got no x squared, got no y squared ma. Okay, why is a linear equation? Because perpendicular bisector is a straight line. Therefore, you are getting a linear equation at the end. Okay, so this is how you must have this type of a common sense so that you will aware, your answer is correct or not. Okay, if you know this type of question, you will end up with a perpendicular bisector, which is a straight line, then you will check your final answer whether you are getting a linear equation or not. If here you end up with something with the x squared, y squared, something wrong already lah, your step, then you could quickly go and check lah. So always when you do maths, when you get the final answer, you must have that type of common sense. Is your final answer make sense or not? Okay, don't get the answer and then quickly go to next questions. Yeah, sometimes you are not enough time. Yes, you maybe will be like that. Okay, but when checking time, maybe This is one of the you need to consider lah, huh? Okay, so these two example finish already. Okay, we go to this example 16. Solve problem. Okay, you go to the questions. Okay, the ropes is a 4 meter. Therefore means the distance is 4 meter. Okay, coordinate of the pole is A, which is a 2, 4. Okay, they want you to find the equation of locus of the goat's thread. Okay, so same thing, you got to set this goat, okay, as a xy. Okay, only you can get the equations. Okay, so GA is equal to 4. Okay, so you start from here and then using the formula, okay, formula of the distance. Okay, G and the A, so x minus 2 squared and then y minus 4 squared, okay, equals to 4. Okay, and then do. Okay, so you have this, then square both sides, okay, and then expansion, okay, and then move everything to the left, okay, and then rearrange. So this is your answer. Okay, that's simple only. You just have to understand the questions. Okay. Okay, maybe I give you a little bit of this extra for you. Okay, we look at this example. Okay, afterwards you can copy this one. Okay, PQR lies on the circumference of a circle with a diameter PQ. Okay, find the equations of the locus of moving point R. Okay, now we go to others already. Just now you have actually altogether 3 types of different locus. Okay, now we have other types. Okay. Look at this. Okay, you have a circle. Diameter PQ. Okay, P the coordinate is 0, 8. Q the coordinate is 0. Okay, now the moving point is the point R. Okay, point R is also on the circumference. Okay, R is here. Okay, so R is on the circumference of the circle, means R is a circle. When the moving point, this R will form a circle, the locus is a circle. Okay, but the problem is how to form the equations. Okay, some of you will say, okay, I think you are going to get the radius. Am I right? And then find the midpoint of the PQ, which is the center of the circle. Okay. And then using RC is equal to the radius. Correct or not? Can I do this way? Come. Anyone want to give a better idea? Okay, Emily Tan say yes. This is same what she thinks. Okay. Okay. So for these questions, when you copy in your books, also you can do the same thing. Okay. First is follow just now what I say or what you think. Okay. So, but I don't want to do it out for you. Okay, because I'm going to show you another methods. Then after that, you do using this method, check and see whether you're getting same answer or not. Okay, so first of all, you've got to find, okay, PQ, the distance, okay, and then R as the half of the PQ, okay, which is the radius. Then you've got to find the point C, okay, the coordinate of point C, okay, where point C is equal to the midpoint of the PQ, okay. Then only you use this formula RC is equal to R, okay, and then get the equations. Okay, this is the method number 1. Okay, now I have another method. Okay, I use red now. Okay, now I draw out. Okay, I join P to R, R to Q. Can you tell me something? If I join in this way, what you can see that I can use it to form the equations? Anyone? You must think, don't I just say, then you just accept. I have hints you for the second method, method B. This one you learn during I don't know which form, but when you learn the circle, okay, PQ as a diameter, and then point R is a point that in the circumference. Okay, when you join the PQ and the R, is what type of triangle it will form? There is a spatial properties on these triangles. Right angle, yes, Ravina. Right angle triangle, thank you very much. Okay, here is a right angle. Okay, if here is a right angle, you also have learned, okay, a perpendicular, okay, this line, PR and RQ, they are perpendicular. Tangent, nothing to do with tangent. It's a right angle triangle. Okay, so PR are perpendicular with RQ. Okay, I want to use what you have learned for the gradient. Okay, for the second method. Okay, she say what? Pythagoras theorem. Let me think. Pythagoras theorem. She want to use Pythagoras theorem. Pythagoras theorem. Pythagoras theorem means you need to know the length of this. The length of this equals, okay, this length, this one will be your method C already lah. I think this is more complicated there. Okay, means PR squared RQ squared is equal to the PQ squared. Can also? No problem. Okay, so you see different methods. After you go and try method A, method C. Method C suggested by Peiji. She say Pythagoras theorem. Now I do method B. Okay. At the end, you compare these three methods, whether get the same answer or not. First thing you have to do. After that, I want you to tell me which method is the easier one and the faster one. Okay. Now, I continue with the method B. Okay. I'm going to use the gradient. Okay, for the PR. Okay, which is the M1. Okay, and the gradient of the RQ, which is the M2, because they are perpendicular. Therefore, M1 times M2 is equal to -1. Okay, I can use this also. Okay, and get the equation. This is just now what we say. Okay, other than the formula of a distance, you can use other formula. Okay, so now I start. Okay, M1. How to find the gradient? Okay, you have 2 points. Okay, y2 minus y1 over x2 minus x1. Okay, so I write y minus 8 over x minus 0. Yes. This is equations. This one you will form an equations. I don't think so lah. Gradient. No, I'm not going to use this, Ravina. Okay. Relation m1 times m2 equals to -1. That one is for you to get the equation in a straight line, you know. This one I will end up with a circle. Okay, so I just get the gradient for PR. Okay, so y2 is this. Okay, so y1 is this. So y minus 8 over x minus 0 for my m1. Then for the m2, I refer to this point and this point. So y minus 0, okay, and then x minus 8, okay, equals -1. Okay, so I simplify. Okay, then I cross, so this the denominator I all bring to right hand side. This is the numerator. Okay. You see or not? Y squared. This is a circle. Okay. Sorry. Okay. Then move everything to the left hand side. Okay. So this is the final answer. Okay. So remember, afterwards you use this and try and see. Okay. And then tell me. Okay. Final conclusions. Okay, which method you like? You just write in your book which method you will choose, okay, to use it. Okay. No right and wrong one. You maybe some of you think of method A, some of you method C, some of you method B. There's no right and wrong which method you want to use. Okay. But if your method A and method C, you don't get this answer, then you got to let me know. But I don't think so lah. Okay. So this is one example that can use other formula to get. Okay, and then this one also I want you to copy. How? You want to see the video again, or you want me to put in your WhatsApp? This one, I want you to know. Okay, you need to know extra things, not only whatever in your books. Okay, so we go through a bit. The general form of a circle. This is what I say. You arrange x squared first, y squared first, y squared, after that x, y, and then number. Okay, then right hand side is equal to 0. Okay, then this is general format of ellipse. Okay, ellipse is look very alike to this circle. Okay, what is the difference for the formula for a circle and ellipse. After I give you one example. Okay, why I introduced to you ellipse is because some of the question it will end up with ellipse. Okay, maybe in your intensive practice 7.4. Okay, this one maybe we will discuss tomorrow or what. Okay, I will see how. Okay. Yeah, and then there is another form of circle equations. Okay, the center radius form. Okay, what's the difference? This is general form. Okay, for circle. This is, we call it center radius form. Okay, for a circle. Okay, so both also is circle, but this is general form and this is center radius form. Okay, so you can write in this way. Okay, if you write in this way, okay, straight away you can read from the equations where is the center and what is the radius. Okay, I don't know when you can apply this, but you know, you can just remember. Okay, so the center of the circle will be the HK, if you are able to write the circle in this form, and the radius is the R here. Okay, so this form will be in x minus h the whole thing squared plus y minus k the whole thing squared equals to r squared. Okay, this one we call it center radius form of a circle. Yeah. Okay, maybe the difference in between the circle and ellipse I don't go through first. Okay, when we see some of the example of ellipse first. Okay, then I will tell you. Okay, if I forgot to tell you, maybe some of you mention to me, please. Okay. So, okay, let us go through homework. Okay, what you have to do for today. Okay, this one. Okay, don't do all. Do the one I take. Okay, and then this one. Okay, these are all. Okay, these are all. And this one also. Okay, this one do 2, 4, 5, and 6. Okay. 2, 4, 5, and 6. Okay, I go through with you a little bit. Okay, you look at these questions. Question 1. Okay, they didn't tell you the radius or the distance. Okay, so you have to find the distance by yourself. Okay, you say that this the locus touches the x-axis as a point. Means here. Okay. So this one you touch at x-axis means what? the y coordinate is 0. So are you able to get the distance? Okay, so point A is 3, means here is 3, here is 4. Okay, so you'll be able to get the distance. Okay, so you just start from here. Okay, so this is for exercise 7.11, the first questions. Okay, now we look at this intensive practice 7.4, question 2. Okay, you see, the moving point S. Okay, triangle ABS always have a right angle as S. This is similar to just now that point S. Okay, right angle. This is similar to just now that the others example that I asked you to use 3 methods to do one. Okay, I believe the easiest way will be this lah. Okay, okay, so you see same type of methods, but the way of asking can be different. Okay, just now you say that the 3 point is lies on circumference of the circle. This question they didn't say these 3 point lie on the circumference of the circle. Didn't mention at all this is a circle or whatever. Okay, but it tell you this is a right angle triangle, that right angle as S. Okay, but you are using same methods, but when you see the question, it can be like different a lot. Okay, then this one for question number 4. Okay, the locus is a quadratic. Okay, the locus here is a quadratic. Okay, so after you see you don't see a circle, you don't see ellipse equations, you will see a quadratic. Okay, and then question number 5, this one the locus is an ellipse. Okay, and question number 5 is difficult. All syllabus also they have these questions, and the new syllabus also they include these questions. Okay, maybe I don't want to give you any hints for question number 5. Let you try first. Okay, but this one is difficult. Okay, question number 6. They don't want you to write out the equation. This one no need equations. They just want you to sketch on it, because it cannot come up with any equations. Okay, this one you can refer to the answer at the back of the book. Okay, you just sketch on it. Yeah. Okay, I think that's all for today. Okay, wait for a while. Okay, any question for me?